syringes of different cross section without needles filled with water are connected with a tightly fitted rubber tube filled with water. So you can have two piston-like arrangement, cylinder piston arrangement, one a thinner one, the other one. Just have a rough diagram, boys. When you solve your numericals, you need to have a diagram. So you have a force. This area is F1, A1. This is force as F1. This area of cross section of the piston is A2. Here the force will act in the upward direction. Here F1 is acting in the downward direction. Okay. What are the values given? What is the diameter of the smaller piston? D1 is 1 centimeter, 1 into 10 to the power of minus 2 meter, or R1 is equal to 0.5 into 10 to the power of minus 2 meters, or I can write it as 5 into 10 to the power of minus 3 meters. Okay, what is the diameter of the second one? D2 is 3 into 10 to the power of minus 2, or R2 is equal to 15 into 1.5, right? So then I'll write this one. Correct, boys? Okay. Find the force exerted on the larger piston. That is what they are asking. Right, boys? If the force applied on the smaller piston is 10 Newton. Correct? The smaller piston, you're applying a force of 10 Newton. What will be the force exerted on the larger piston? So both the pressure should be the same. So according to Pascal's law, F1 by A1 must be equal to F2 by A2. Can you calculate F2, boys? Okay, calculate F2.
Ma'am, in Pascal's law, pressure is same at all points, right?
Yes, pressure will be transmitted equally. When you create a pressure at one point in a static fluid, the same pressure will be transmitted to all other points without any undiminished. That's what.
Now, does that include the gravitational force
Yes.
or potential? Or
Gravitational?
Potential, right? Wouldn't it be there in the
gravity, effect of gravity?
Yeah.
The effect of gravity doesn't matter, boys, provided your fluid should be at rest, static fluid.
Okay.
30, okay. Are you get 30 or 90? Just check, boys, is it 30 or 90? See the error. Boys, are you getting 90 newtons?
Yes, ma'am.
Yes, ma'am, 90 newtons. Yes.
Okay, fine. Now look at the second part of the question. If the smaller piston is pushed to 6 centimeter down, how much will your larger piston move out? Are you clear? Boys, the question is, if the smaller piston is moving down to a certain distance, what is the distance? If the smaller piston has moved to a distance of 6 centimeter, naturally the larger piston will move up. Yes, sir. Larger piston will move up. The question is, to what distance is your larger piston is going to move up? Right, boys? Now, think what you have to remember is that the volume of the liquid, volume covered by this movement of the smaller piston must be equal to the volume covered by the larger piston. That is a key factor over here. Water is considered to be perfectly incompressible You cannot compress water. So even if you compress, if one goes down, the same extent the other one also will move up. So volume covered by the movement of the smaller piston inward is equal to the volume covered outwards due to the larger piston. So what is volume was? What is generally volume? It is area into height or area into length. Volume is area into length. So what is the volume covered? This is the volume covered by the smaller piston. When the smaller piston is moving down, the liquid column would have moved down by a volume L1, A1. When you compress, your liquid column would have gone down to what extent the volume would have come down. See, this is the volume of liquid moved down in there in the smaller piston, right? Sorry, smaller cylinder. Volume of liquid moved down in smaller piston. The same amount should smaller cylinder. What is L2A2? It is the volume of the liquid which has risen in your second cylinder. Yes, okay, boys. And now you calculate L2. What is this volume of liquid moved up in larger cylinder? So equate and just get the values, boys. The volume of the liquid moved in the smaller cylinder must be equal to volume of the liquid that has gone up in the larger cylinder. So from where you can find your value of L2.
Yes, ma'am.
L2 is the
I got 2 by 3 centimeter.
2 by 3 is 0.
Yeah, okay. Yes, ma'am.
Shall I move for the next numerical?
1 minute, ma'am.
Okay. Shall I move on to the next? We calculate this. In a car lift, compressed air exerts a force F1 on small piston. That is what is happening in car lift. A compressed air will be forcing the smaller piston so that the car will be moving in the upper one. Okay, can you draw a rough diagram? Draw the rough diagram was just draw the rough diagram of a larger piston and a smaller piston, sorry, cylinder. So you're applying a force F1 over here. On top of your larger piston, you have a body. Right. What is the weight of the body? Weight of the body is M into G.
Ma'am?
M into G is acting downwards. Yes, what happened was?
Ma'am, are you sharing something?
Yeah, you can't see? You can't see?
No, ma'am.
No, ma'am. No, ma'am.
Why, what is? Throughout, you were not able to see, boys.
No, we saw the previous question. We can't see this question.
This whole question we couldn't see, ma'am.
It's okay, fine now. Is
Yes,
it
ma'am,
fine?
it's fine? It's fine.
Ma'am, can you show the
Take
previous
something
slide? I'll take a screenshot.
It's your textbook numerical, boys. So worked out.
Okay, ma'am.
The next one, you better draw a diagram, boys. You should have a rough diagram. Now, can you see the slide? Can you see the slides, boys? Check. Can you
Yes, ma'am.
see
Yes,
the
ma'am.
slides?
We can see.
Just draw a rough diagram. You have a wooden block lying on the surface, which has to be lifted. F2 is acting upward. The weight of the body is acting downwards. Then you have applied a force of F1 on the smaller piston. Now look at the question. The pressure is transmitted to the second piston of radius 15 centimeter. If the mass of the car to be lifted is 1,150 kilogram, calculate the force F1. So what is F2? What will be F2 was? See, if you want to lift a car, if you want to lift this object of weight m into g, what should be the minimum force? Was if you want to lift a weight of m into g up, what should be the minimum force? F2.
The force should be
F2 equal to F2. Right? If I want to move, suppose I have an object of 50 newton, weight of the object is 50 newton. If I want to lift this object, I should apply a force. What should be my force? My force should be either greater than 50 newton or equal to 50 newton, correct? If I want to lift a body of weight of the body is 50 newton. If I want to lift the body up, the force I should apply should be either equal to its own weight or greater than that weight. Okay. So here in this case, what is the force F2 was? What will be force F2? F2 will be equal to M into G. So that will be 1,350 into 9.8 newtons. Now the question is, what is the pressure? What will be the pressure? P is equal to F2 by A2. So 1350 into 9.8. What is the area was? 3.14. What is the area of the piston? 15 centimeter second piston. 15 into 10 to the power of minus 2 the whole square. Calculate.
Ma'am, it's a piston with radius 15 centimeters that's connected. That's with the car.
Yeah, because the larger piston, right? So you find what is the pressure they are asking. You calculate the pressure. They're asking F1 also. F1 you can easily calculate. F1 by F2, sorry, F1 by A1 is equal to F2 by A2. The second part, will you do it as a homework, boys? F1 by A1 is equal to F2 by A2. This is Pascal's law. So F1 becomes equal to A1 into F2 by A2. This you can do by yourself. I'm just doing the second part. Calculate the pressure. You can do that. What is the value? 1350 into 98. Suppose I make this as a whole number.
Ma'am, you have to over the value of P.
Huh? It's diameter, right?
No, ma'am, we have to leave the value of P as it is, or do we need to calculate it?
G, value of G, 9.8. If you want to round it up right now, you can round it up to complete it, boys. Okay, you can take, I'll take it as 10. Suppose if you need to take it as 10. So if I take this as 10, then in that case, 3 times, 2 times, 3 times,
Ma'am, in the diagram, F1 should be exerted onto the piston, right?
Yeah.
Okay, ma'am.
I don't know. It's roughly, I'm putting everything rough value. So I'm getting it as 2 into 10 to the power of 5. I don't know. Let me check. Yeah, 2 into 10 to the approximately. Finished. Now we'll go for, boys, so far you are studying about fluids which are static, right? The next part of the chapter will be fluids which are in motion. Yeah, boys. Okay, now we'll go for. Now suppose the next one is variation of pressure with depth. Just write the subheading, variation of pressure with depth. Boys, they will not ask you to derive. Just what you can do is only I need the diagram for this. Okay. I'll do this. Variation of pressure with depth. Just diagram is enough. Boys, now suppose if I have a container which contains a liquid, right? I want to find the pressure. I want to find the pressure, say, at point P, which is at a height of, sorry, which is at a depth of h below the surface. 1 second, boys. You should know what you are finding. Now, let me consider a fluid or a liquid in a container. Now, we'll take it as a liquid. Now, suppose I want to find, say, the pressure at point, say, at point C, well within the liquid column, which is at a depth of h from the below the surface. Are you clear, boys? That is what is your derivation. Right? Pressure as at a given depth. Pressure of the liquid at a given depth. Now for that, what you need to do, right? Now what you have to think is that you have to consider an imaginary cylinder. Your aim is to find I want to find pressure at any point inside the liquid, which is at a depth of h meter below the surface. Is that clear?
Ma'am, your voice is very low. Below the surface. Now, what else we need to do? For that, I'm considering a imaginary cylinder. Now, imaginary cylinder of the liquid. I'm considering the imaginary cylinder of the liquid. Now, the liquid in the cylinder, the entire liquid is static. Yes?
Ma'am, can you repeat what he said before? Like your voice was too low.
Fine, boys. Now, I have a liquid column, sorry, a container which contains a liquid. I want to find the pressure of the liquid at a point A, which is at a depth of h meter below its surface. That is your aim. For that, what you do is you consider an imaginary cylinder. You are considering an imaginary cylinder. This cylinder is having a liquid. I'm considering an imaginary cylinder of the liquid column. The height of the cylinder is h. The area of cross section of the top surface and the bottom surface are the same. Are you clear? I'm considering an imaginary cylinder of the liquid, imaginary cylinder of the liquid, and this cylinder has a height h, and both the area of cross sections are going to be the same. So this cylinder will contain what? The liquid. Okay. Now I have two surfaces, surface 1 and surface 2. Now if the liquid is stationary, then the cylinder should also be stationary. Right? The cylinder should be at equilibrium. It should be stationary, which means what? The net force acting on the cylinder should be 0. Is that clear, boys? The entire liquid is static, so that the net force acting on the cylinder should be 0. Now let us consider all the forces acting on it. The lateral forces.
Ma'am, should you
All
write
the-
anything?
Nothing, boys. Just listen.
Okay, ma'am.
So all the forces which are acting along the sides are going to be equal in magnitude and opposite in direction. So the lateral forces are 0. Net lateral force. Net lateral forces are adds up to 0. Now only the forces which are acting in the upward and downward direction should balance. Now look at this, and now let me look at the diagram. F1, there is a force F2. Then there is a force mg. Right? If this cylinder has to be balanced, the net forces F1, F2, and mg should add up to 0. Are you clear, boys?
Yes,
Sideways forces all cancelling out. All the forces which are acting along the sides are cancelling out. Now I have to check the net upward force must be equal to net downward force. Now I want you to write what are the net downward forces acting. What is the net downward force?
Ma'am, so the body is in equilibrium, right? It's like not moving. No, ma'am. Ma'am.
Ma'am, we can't
Boys,
hear.
sorry, boys, sorry. I'll take all the downward forces negative, upward force positive. Upward force is what? F2. Downward force. Downward force. Because they are acting in the opposite direction, I have put negative. What is force? Force, what is the general formula for pressure? Force upon area.
Ma'am,
Okay.
should we write this?
Yeah. You can write net force acting. Net force acting on the cylindrical liquid. No? The net force acting on the cylindrical liquid. Okay, what is the general formula for pressure? Pressure is equal to force by area. So what is force? Pressure into area. Because in a liquid, you could have seen in a swimming pool, the pressure of water
Ma'am, one
keeps
lakh
on
speed is
increasing and you're
started.
going down. Next class I'll finish it. Tomorrow we have 2 periods, right?
Yes, ma'am.
Physics is tough. Physics
Thank
is
you,
tough.
ma'am.
Thank you.
No, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Tomorrow last